All right, so here, what we're going to look at, we're actually skipping chapter 7, so you don't have to worry about chapter 7. You know, anything I don't cover, you can skip. You don't have to know. I mean, you should be reading any section that I cover in the book, but anything I skip, you don't have to know. All right, so here in chapter 8, what we're going to look at is the concept of probability. And basically with probability, it's really just trying to calculate how likely something is to occur. That's really what probability is, and you're using mathematics to determine how likely something is to occur. Probability is used all around us. You know, with the lottery, for instance, they say things like, you know, you have a 2% chance of winning if you buy one ticket. I don't know if it's actually 2%, but I made something like that up, but you've heard things like that before. You know, that's probability. You know, how likely something is to occur, how likely something will not occur, that's all related to probability, which people use math to study. We'll see that today. And we'll see, maybe not today, but we'll see some basic concepts associated with probability. We'll see calculating odds, you know, like the odds are in favor of a certain event occurring, like the odds are against someone winning the lottery if they buy one ticket, because how likely they'll win, the chances are so small. I know with gambling, for instance, you know, if you go to Las Vegas or any casino, you know, there's always, you know, with gambling and stuff, those card games, how likely you are to win, how likely you are to get a jackpot, you know, that's all related to probability. And we'll also see expected value. So probability, again, we're basically measuring how likely something is to occur using mathematics. Okay? Now, this will come up as well. Let me just get that right. Okay. Here we go. So I had the wrong set of notes up in my iPad, so I just had to fix that. Okay, so basically, if you're given 3 numbers, x, y, and z, where, as you can see from here, we're assuming y and z are not 0. This is just an algebra. This is just a result you can prove easily using algebra. I mean, it really comes about from how you divide one fraction by another. You know, then there's some cancellation. Or you could just multiply top and bottom of this big fraction here. I think they call it a complex fraction. You can multiply top and bottom by y, and you'll be left with x over z. It's just something that comes up in this chapter, because we will be working with fractions a bit. So I felt better posting this. Okay. All right, so this will come up in this chapter. Now we can really formally answer what exactly is probability. It's just how likely a certain event will occur. Again, like with the lottery, what's the probability of winning the lottery? You know, how likely will you win the lottery if you buy one ticket? How likely will you win the lottery if you buy 20 tickets? You know, that kind of thing. You know, if you're playing poker at a casino, how likely are you to get a full house? You know, how likely is it that you're going to have the hand you'll get is 3 of a kind? You know, that kind of thing. Probability is how likely those events are to occur. Events like that, that is. There's actually different viewpoints people can take. One of them is subjective, which basically is an educated guess. Another one is experimental. That's where you actually do the experiment and repeatedly, and you record your results. You know, like for instance, with flipping a coin, how likely is it if you flip a coin, you know, the coin could land heads or tails up? How likely is it that the coin will land tails up? Well, for experimental, you would flip a coin a bunch of times, not just once, not just twice, but maybe hundreds or thousands of times. Or somehow you would simulate it on a computer. And then you would record how often the coin landed tails up. So if you did this 100 times and it landed, and 50 times about the coin landed tails up, you would say, oh, well, the probability then would be 50 out of 100, which is a half. I mean, with computer software today, experimental seems more feasible because, again, you could do simulations. What we're going to focus on is theoretical. That's where we're basically going to use math theory to analyze probability. And that's what we're going to consider now. And before we get to that, we need some terminology. Again, math does have a lot of terminology. We have experiments, and that is a controlled operation that yields a set of results. Like flipping a coin, let's say, that is a controlled operation. Or let's say you have a standard deck of 52 cards, right? Drawing one card at random would be an experiment. And from this experiment, results you can get, those are called outcomes. So the coin landing tails up would be an outcome. Or from a standard deck of 52 cards, drawing an ace of hearts, that would be an outcome. Okay. And they also have events. That's actually any sub-collection of outcomes from an experiment. There actually is some set theory here. That's actually what they do in chapter 7. But again, we skipped that. So I'm trying to eliminate as much set theory as I can. I mean, there's the word set down here, but we'll get to that. But an event is just a sub-collection of outcomes from an experiment. So let's say you're tossing a coin, not just once, but let's say 3 times. One event could be that the coin lands heads up only twice. And that can happen because if you're tossing the coin 3 times, right? It could be heads, then heads, then heads. Or it could be tails, then heads, then heads. Those are sub-collections of an event that the coin lands heads up 2 times. At least 2 times, I should say. It's just a collection of outcomes, okay? So it could be one outcome in an event or a collection of them. And then there's this notion of simple events. Those are the events that can't be broken down any further. So for instance, with tossing a coin, okay, 3 times, let's say, and one outcome could be heads, then tails, right? So the first toss, the coin lands heads up. The second toss also. The third toss, it lands tails up. That would be a simple event because, again, you can't break down that event any further. It's not like the event where the coin lands heads up at least twice. You could break that down further because you could say, well, you can get all 3 tosses, the coin could land heads up, or you can have tails up, then 2 heads, that kind of thing. You'll see what I mean when we actually do some examples. I mean, hopefully what I'm saying here makes sense. The sample space, that's just a collection, which really is a set of all possible outcomes. That's just what it is by definition. Okay, so we have experiment, outcomes, events, simple events. Those, again, are the ones you can't break down any further. And then there's the sample space. Or maybe this will help with the simple event. If you're rolling a 6-sided die, right? You record the number that is facing up that you roll, right? So you can roll 1, 2, 3, 4, 5, or 6. Any of those is a simple event, as opposed to the event rolling an even number, right? Because you can roll a 2, a 4, or a 6 to get an even number. So the 2, 4, and 6 would be simple events. The event would be rolling an even number. Anyway, let's get to let's do some more terminology, and then some examples I think will make it easier to understand. So let's suppose we toss a coin twice. Okay, the sample space then would be heads, then heads, heads, then tails, right? So the coin lands heads up twice. It lands heads up on the first toss, then tails on the second. Here, it's tails, then heads, And then here, it's tails up twice. So these are all the possible outcomes you can get from the experiment of tossing a fair coin twice. Some simple events here would be, the coin landing heads up, then tails up, right? So this would be a simple event. You can't break that down any further. Or the coin landing tails up twice. These are simple events. You can't break them down any further, as opposed to the event that the coin lands tails up only once. This is an event, not a simple event, because you can ask, well, how does that happen? How could the coin land tails up only once? You can get heads then tails, or tails then heads. These are simple events. And there's another one, the coin never lands tails up. Well, that would be just getting heads twice, landing heads twice. Okay. As another example, suppose we roll a fair six-sided die. Okay, so what would the sample space be? Well, again, it would be, since each side is labeled with a number, 1, 2, 3, 4, 5, or 6, these would be all the possible outcomes, the sample space. Because if you roll a fair six-sided die, you can roll a 1, a 2, 3, 4, 5, or 6. You can roll any of those. So simple events then would be, rolling a 2, rolling a 1, rolling a 3. Those are simple events. But an event such as rolling a number larger than 3, well, that's an event, but that's not a simple event. Because how could we roll a number larger than 3? Well, we can roll a 4, a 5, or a 6. So we broke it down, right, into these events, rolling a 4, a 5, or a 6. So this is not a simple event. It's an event, though. Or rolling an even number, right? You can roll a 2, a 4, or a 6. That's how you can roll an even number. So this would not be a simple event. I hope that makes sense what I'm trying to say.